Was it just 177?
Okay, we'll see if that works. All right, guys. So this one, chapter 168. Okay. This is nothing different than anything else we've done, to be honest. I'm sure there's something about this problem that threw people off, though. What's the first thing you do? Yeah.
I think what threw people off is remove the parentheses so they don't know what.
Oh.
Because that's what I thought at first.
How do you get rid of the parentheses? What do you always look for first?
Distribute.
Once you distribute, are you still going to have parentheses? No. That's all they meant. That's all they meant. Instead of saying remove parentheses, they should have said distributed. Or they could have just not said shit, just said simplify. Because we know to distribute first, right? All right, so that's explained. So, I mean, once you distribute, you get... Boy, I look my X in. There you go. So what's your like terms? What goes with this guy? Yeah. So you got 11 minus 8 of those things, so you got 3 of those things. And then you got how many X's? 10 X's.
That's what I forgot, that like you had the exponents, but...
Oh shit. What are well, no, real quick, let's settle this right now. What are exponents based on? What operation are exponents based on? Multiplication. So they will only change if you multiply or divide. Because that's what they're based on. Right? What changes when you add subtract coefficients? You change. Because you're keeping track of how many of these things you got. So if you told me the answer was this, I'd say, I don't see any x to the 8s anywhere. How do you get 3 of them? Right? So what do I see 3 of? 3x to the 4th that are left. And what do I see 10 of? 10x's. So, but if I had 3x times x to the 3rd, or even x to the 4th, what would that be? That would be 3x to the 5th. Then the exponent changes because you're using the operation it's based on. Good? Okay. Anything else from homework stuff? Yeah.
If we do the calculations of parentheses first,
Are they like terms?
definitely
I have an x subtracting an x to the 4th. They're not like terms. This, cool. What does it take to be like terms? Same variables, same amount of each variable. So there was a question in the homework that was something like 5r squared s and 9rs squared. Are those like terms? No. I can't put them together. 14 what? I ain't got 14 of anything. I got 5 r squared s's and 9 r s squares. They are totally different things. You can't put those together. You can see that? What does this mean? Doesn't this mean r squared s plus r squared s plus r squared s 5 times, right? Isn't that what? And this means rs squared 9 times. How could they possibly interact? They're talking about different things. They're consolidating different things. 5 cats and 7 tables. I got 12 cat tables. Shit. No, you don't. Meow. This is weird. Do we eat on this thing? No, we don't know gene splicing. Does that make sense? So, like terms. Same variables, same amount of each variable. So could you put these together? 4ab cubed plus 2b cubed a. Come on. Think about what I just said.
Yes.
Oh, yes.
What letters do they have? A and B.
Oh,
Yeah, some fool put the other one out of order, right? So who cares? What's the operation in this term? What's all the operations? Times, right? So can't I just make this A, B cubed? Do they both have an A? Do they both have 3 B's? So they are like terms. I have 6 AB cubes. I just put it in alphabetical order. Convention. That's what we do. Just so they don't look like they're not like terms. It's kind of evil, but oh well, just gotta be careful with it. Okay, cool, I like it. Anything else from homework stuff? Somebody overhears. Nothing, nothing. Yes?
What about the pieces?
Oh yeah, alright. Yeah, this one's kind of like they just kept going, they just couldn't stop. Like, who made this problem? Alright. Let's see, 56ers. I think that's right. Yeah, buddy. So the best way to look at this problem is the people that are really good at math, just naturally, are the ones that are able to break things up into parts. So they can focus totally on one part and not give a shit about the other part. What does order of operations say I do first? Parentheses. Which part of this is the parentheses part? Yeah, because brackets are just a form of parentheses. I don't give a shit about any of this stuff. All I care about at first is that. So then my problem becomes that. Already much easier to handle, right? The people that have trouble with math, nothing, it's not like you're bad or not a good person or just you suck, whatever. It's just you have trouble letting go. You kind of keep all of this in your head at once. Realize you don't have to, right? I don't care. This just comes along. Just shit. Okay, what do I do in here? Because that's my whole world right now.
Parentheses.
Do you have to distribute? You could, but my God, you're going to make mistakes. Don't. You only distribute when you have to. And you only have to if you can't do this. But what is 4 minus 7? Negative 3. And now I'm still working in here, right? So 16 divided by negative 3 minus 5 comes from the right. 3 minus 1 is 2. What do you do here? Alright, that's enough I'm going to do for you. Keep going. Right? You get the inside done, then negative 5 times that, and then you cube, because that's right. Keep going. Then you start worrying about this stuff. It already looks a lot better, right? And see how this part just repeat, because I'm not looking at it yet. I'm starting with the parentheses first. I don't care about the whole thing at once. That's insane. It's sort of like when we do word problems, which we're going to get into very soon. People think they're supposed to be able to read it and set up the equation right away. Either you want to do that so it's over sooner, or you think that you're supposed to be able to. That's insanity. That's insanity. Right? I'll show you how to kind of focus on what part when. Okay, maybe. That's later. Anything else from homework stuff? Yes?
Section 2 for chapter 2, the last 3 questions,
Let's see.
I looked about the numbers.
2. Let's see. What was the assignment? Somebody have their little sheet? I gave mine. I think I gave all mine away.
It's 10 to 80, every fifth one, and 99.
All right. So 99. Yeah. Anything after the part where it says synthesis? If you've done the homework, you've seen that word. 99 shows up after the word synthesis in the homework. That means it's kind of like a bonus problem, to be honest. Those go a little bit above and beyond. So you had trouble with 80, obviously. I've already forgotten who asked that. Yeah. Oh yeah, let's look at 80. It's got some beautiful some beautiful fractions. What did I do with my? Did I have it?
The rag?
Yes.
It's under your desk.
Where? Oh,
Under your text.
oh, jeez. So nice to myself. All right, I'm gonna leave that over there. Let's see. We're doing it. So where'd it go? 80. There we go. Going to have to tell me if there's a day that we don't have car alarms going off. It's not today. All right. 80 says 3 halves, 2 is 5. Equals negative 15 halves. Okay. I want to show you something. See if you guys get this. Now watch. This is going to seem completely unrelated at first. How do you do 2 times 3 times 5? How would you do that? I asked you 2 times 3 times 5. How do you do that?
2 times 3
Thank you. How do you make macaroni and cheese? Make macaroni and cheese. Oh, I'm done. What would you do exactly? Yeah, you do 2 times 3 is 6. Now, what would you tell this person? What did that person do? Is that right? What would you tell them?
Times the 6 by 5.
What did they do wrong? Can you see? And how many 2's are there? 1. So how the hell does 3 get a 2 and 5 get a 2 also? Do you see that? Now, watch. What sucks about this equation the most? Fractions. How do you kill a fraction? Multiply by the LC. In this case, it's awesome. They're both 2. So what do I multiply by? 2. You guys see how this applies?
Yeah.
Once this 2 dies, it is gone. There's no other 2 for this dude. He's dead. And now look what it looks like. Now it's got a 3 equals. Yeah, dude. You can always immediately kill your fractions in an equation, because you can multiply by the number that would kill all the bottoms. In this case, they're all 2. That kicks ass. Yes, sir.
So had they had different denominators, would you have to find the LCD?
Yes, I would make them both first have the same denominator and then multiply by whatever that is. Yeah. So if this would have been what would make sense? A 7. A 4 would work. If this would have been a 4, I would have first multiplied top and bottom of this by 2, so they both have, and that would multiply by 4, because then all the 4's would cancel. Yeah. So if I know what to do when they are the same, if they're not the same, I make them the same first, and then I know what to do. I like it. And then you can keep going. It's not bad now, right? Is that cool? Did you have to do it this way? No, you could distribute the fraction, but do you want to? No, neither do I. I could. It's really good at math. But I don't want to, because that just makes one more place I can make a mistake. Okay. I don't mind showing off about that, because that's my one skill. Anything else from homework stuff? So, 60? 60? Let's see. 60 looks like.
For 2.2?
I think she said chapter 1, right?
Yeah.
Yeah. Am I? No, I'm still in 2.2. Thank you for that. Chapter 1, Jeff. 60. There it is. Oh, yeah, that looks. All right, this is chapter 1. This problem, I think, explains why everybody always thinks division is last. In this problem, division is last. Let me write this in a weird-ass way that you're not used to. And then I'll erase what I'm going to write because it's a little weird. So if I try to write this more in a straight line, I haven't done it correctly. That's not correct. I want to divide this by this. So that big-ass division bar has these hidden parentheses. We don't need to write the parentheses because we can see the big-ass division bar separating them. But if I wrote them in one line, I have to put the parentheses in to follow order operations. But I think this kind of problem makes everybody think division's last. No. If I had it like this, division would not be last. Not at all. Yes, sir?
Looking at number 56 then, which you have it on the board still.
Yeah.
Are you dividing the 16 by the whole rest of the equation, or are you just
No.
16 by the negative 2?
What's being divided?
16 by negative 2.
Yeah, just by negative 2 cubed. So I'll do the exponent next, and the division. What's the very last thing you do in this problem? That's subtraction, because that's at the ass end of penwise. Yeah. Oh, I got you. So it's something minus something. That's the right way to look at that. So you got to figure out what that something is and what that something is, and then you can finally subtract it. This is something divided by something. So you got to figure out what the top is, and then you can figure out what the bottom is, and then you can divide it. So really it's two problems. How do you do that top problem? What would you do first? Yeah, parentheses. So it'll be 4 times 10. What's 7 times 9?
63.
Yeah, what's 18 minus 8? 10. Did I write down correctly?
Yeah, you did.
Yeah. Okay. Is that cool? I mean, on the top, what would you do? What do you do? What's order operations say very first thing? Please, parentheses, you do inside there first. 18 minus 8 is 10.
Oh, I just
Oh! That would work too, because distribution is a valid property, but I really only distribute when I have to, which means I would only distribute if it was something inside that I can't put together. But the distribution would still work. And over here you get 7 times 9. On the bottom you get 81 minus 64. I like it. Is that cool? That gets you started? At least I'm not going to do the whole thing for you because it's not my homework. Is that enough to keep going? Whoever asked that question? Yes? You sure? What would you next? 4 times 10, 11. So finish the top, finish the bottom, and then the last thing you do is reduce that. I like it. So it is a top problem and a bottom problem. So you do it just like that. You tackle the top problem, you tackle the bottom problem. And the last thing you do is worry about the whole thing as one big fraction. Okay, anything else from homework stuff? Okay, let's get back into kind of where we left off here. We're going to get into the next little section. Blah, blah, blah. Let's do some more, let's do a couple more fraction equations. Just because they are our most hated thing. Poor little fractions. They didn't want to live, we made them. Like the little Frankenstein monsters that we don't love anymore. That was weird. Okay. So something like this. 5/12 minus x over 4 equals 7/3. I like it. You would, Jeff. If only every denominator was the same number, I could multiply by that number and kill all of them. They're not all the same number. Now, there is another way to do this. Just multiply by the LCD. Now, there's a reason why I really push the way I'm going to do it. Because when the bottom becomes x plus 1, x squared minus 1, x minus 1, you're going to want to do it this way. So I want to get you used to this way. So what's the LCD going to be? It means what? What's this dude need? 3. What's this guy need? 4. So then I get 5/12 minus 3x over 12 equals 20 over 12. Okay, and then I can do what I said earlier. What can I do?
Multiply all of it by 12.
Multiply by 12. The worst part about this equation is the fractions. Since it's an equation, I'm allowed to do shit to both sides. The only thing I'm not allowed to do to both sides is multiply or divide by 0. Because then everything in the universe would be 0 equals 0, and that doesn't mean shit. But I can multiply both sides by anything I want to, so I'm going to multiply by 12. So here's technically what's happening. But then what would always happen with 12? It would always distribute. Do you guys see that? So I just always write it next to each piece. Just because that's what's going to happen anyway. And all those 12s die, right? There's no 12s left alive. That 12's dead, so I'm left with a 5. That 12's dead. That 12 has died. I always get somebody get 60 and 36x. No, the 12 died. Yes?
Or did you have to like write it down, just to show us what you were doing? Like, 'cause you could just solve the top and you got.
Yeah, you could, this little shortcut, you could just, you know the bottom's gonna die, so you just rewrite the tops. That's beautiful. Yeah, I try to show every little step when I can. Yeah. As long as you make it clear what you're doing, I'm okay with skipping a few steps. And now, of course, now this looks more like a standard. What's in the wrong place? The 5's in the wrong place. So I subtract. I still have people that are going to do this because they see the subtraction, but what's 5 plus 5? Freaking 10. I didn't make it better. I made it worse. I want to kill the 5. Dead. Over there I get 23. So the last step is almost always divide last, right? Divide by negative 3. I like it, so I just get this freaky negative 23 thirds. Shabow. How you guys doing? That's the beautiful thing about equations. Very often, if there's something I don't like about an equation, I can get rid of it. Because it's an equation, I'm allowed to do stuff to both sides. What about this? Here we go. Something to realize about decimals is they are fractions. All decimals are fractions. In fact, all of these are out of 100. Right? So if you could even write this as 8 over 100 and so forth, and then it would be just like this. Or you can say, how many times do you have to move the decimal over to make it a whole number? Every single one of these. Twice. So I'm going to multiply by 10 would only move it once. Multiply by 2 10s, 100 to make it move over twice. Do you guys see how that matches? What's underneath this is a fraction, 8 over 100. So just like here, I would multiply by 100 to kill that bottom. Or just look at it as a decimal, move it over twice, means to multiply by 2 10s, 100, to make it a nice whole number, right? So if you don't like fractions, you can kill them. If you don't like decimals, you can kill them. Just gotta live with yourself. That's a murderer, but that's all right, you can deal with that. So multiply everything by 100. So all that happens then is this moves over twice. 8x plus 12 equals 17, negative 17x. I like it. And that looks so much better, right? And then what's in the wrong place? The 8x's are in the wrong place. They're not with the x's on the other side, so I... That's the other thing about solving equations. It started off looking like this. I did something and changed it. Forget about this shit now. It doesn't exist anymore. This exists. I think sometimes this kind of comes back in your brain and you're like, do I have to do something? No, you killed them. They're gone. You work with what you've got now. You don't have to modify anything later. Does that make sense? Some of you guys are always like, what do I do because I did that? Nothing, because you did a step. You killed them. Now you're working with this equation. These equations are the same, actually, yes?
More times than not, even though you killed the fraction, is the answer still going to come back as a fraction? Like,
Very often, very often. But if this would have been like, 21, then it would have happened to reduce. But there's more chances for it to be a fraction. It's kind of lucky to have it reduce. So yeah. And then what's the last step here? Negative 25, I like it. Divide by the thing with the x. Yeah! So I get x equals negative 12 25th. Okay, how are we doing?
Yeah.
Okay. Now.
I have a question.
Yes?
Okay, so how did you get 8x from multiplying 0.08 100?
All right, now watch. Okay, let me focus on this for a minute. Here we go. Our number system is based on 10. every time I multiply by 10, I move the decimal back once. So so you can look at it two different ways. 0.6, what does that look as a fraction? 6 tenths. So if I multiply by 10, I should get 6. So look here, effectively, right? Is that cool? If this equals this, if we multiply by 10, they better still be equal to each other. So what's the shortcut here? To make this a 6, I move this over once. Right? I mean, if I have 7, what place is that in? The ones. If I multiply by 10, doesn't that make that go to the tens place? So effectively, I've moved the decimal over just so that's in a bigger place. If I divide by 10, I'm going to move the decimal the other way. Divide by 100, I'm going to move it twice this way. You guys with me? It's just because decimals fit into our number system. Our number system is based on 10. So multiplying divided by 10 is remarkably beautiful with our number system. This is actually what the metric system is based on. Is 10. Do you know we're the last country on the face of the earth to not use the metric system? It used to be 3 of us, and now it's just us. Right? Think what you will.
So multiplying to the left, dividing.
Yeah, so if I had 0.0375 times 1,000, how many zeros are there here? 3. So it's going to move the decimal 3 times bigger, right? 1, 2, 3, so that would be 37.5. Every factor of 10 moves it once. So 1,000 is 3 tens, it's going to move it 3 times. Please let that part be nice. Cool. I like that. Oh yeah, here we go. So, for some reason, people get to a point where they're pretty good with solving equations, and then they think that this kind of problem is completely different. Solve for B. So I'm starting off really, really, really nice. But this is exactly as if, look at here, look, what's the difference between these two problems? In my eyes, not a damn thing, because I'm going to do the same thing to solve this problem. So they're effectively the same problem. What would you do here to solve for B? Because here's the B, here's the shit I don't want with it, so I'm going to get rid of the shit I don't want, right? So here's the same idea. It's an A, who gives a crap, who cares? Here's the B, what do I not want? The A, how do I get rid of the A? Subtract A. Now here's the other place where people freak out. Read this. What's this say? Okay, that's what you write. You don't write AM, you don't suddenly make it multiplication. Like I always say, you're like the math Jesus. Subtraction and multiplication. Oh, like, come on, man, make some more. All right, so let's try something a little more complicated. Too bad. What if I had? Let's see, what do we got? Yeah, let's do that. QE plus VB equals F. Solve for E. So what you do, this is actually the same thing you do when there's numbers around, but it's a little bit easier to focus when there's numbers around. What term has your E in it? Because that's the variable I'm trying to solve. Why is that not by itself over here? What else is with it? Stupid VB. How do you get rid of that VB? There you go, see? Keep going. No, don't tell me. Keep going on your paper. Finish this. Finish it. Like you said, the first step is subtract VB. We'll just have one more step after that. So subtract VB. So we get QE equals F minus VB. Now, somebody pointed out once to me that this is even better because there's no numbers. That means I can't do it. I just write it. What's F minus VB? F minus VB. I don't know what this shit is, right? So on one level, this is kind of nicer. You actually don't have any work to do. You just got to collect all the crap. You don't actually have to do it because you can't. So like you said, like somebody said, what's the last thing to do? Why is my E not by itself? Divide by Q. So you get E equals F minus VB over Q. You have got to see how every step made sense. I'm trying to get the thing with E in it by itself first. Get rid of the other stuff. Once I get the thing with E in it by itself, I can divide by the other parts of it. So it gets really totally by itself. Maybe not. Okay, let's see. Let's try another one. Let's see if you guys remember what you're allowed to do here.
Are we doing it, or are we waiting for an answer?
Waiting to see what people
Oh,
let you guys write it down.
I thought we were gonna. I was like, oh, okay.
Okay. What do you guys think is a good first step?
Multiply by tailgate.
Yeah. There's a thing I don't really don't like. The whole thing sucks. There's just one number and it all just sucks, Jeff. But the worst thing about it is it's got a fraction in there. Well, let's kill it. It's an equation, so I'm allowed to kill it by multiplying both sides. Multiply both sides by? What happens to the W on this side? There's no W left to go in here, right? I see how slowly I say that because I get so many people that do that somehow. Little zombie W, it's dead. So now you got C plus 2D, D Jeff, equals AW. One last step to get C by itself. Subtract 2D, I love it. So if the better you know how to solve equations, the easier these should be. Part of your brain goes, there's no numbers in this shit, but you should just say, that's better, brain. That means I don't have to do computational stuff. What's AW minus 2D? AW minus 2D. I don't know. There's somebody else to worry about. So, one level of this is, of course, you're all thinking, or somewhere in your brain, you're like, why am I just playing around with this shit? What's the point? The way this equation was written at the beginning was really useful for if I know C, D, and W, and I want to know A. You guys see that? So if I told you if C was 2, D is 5, and W is 6, could you figure out what A is? Totally, right? That's easy shit, because it's already solved for A. But what if I knew what A was, and W, and D, and I wanted to know what C was? And I had to do that 18 times in a row. Wouldn't I rather have an equation that's already solved for C, so when I throw these in, it's done, it's done, it's done, it's done every time? I know on one level you're like, sure, but But if any of you take statistics, it really happens a decent amount in there where you want to change the formula around to be more useful in other situations. This is great if I want to know A. This is great if I want to know C. These are both the same equation, it's just this is more useful sometimes than this one. So you have to be able to play around with the variables to rewrite the equation. Okay. Here, let me write one that's a real. This one's almost a real equation. This is the force that a particle feels in an electric and a magnetic field. Did you have to know that to do anything with it? No, I didn't say that for any other reason than a lot of these you're going to see in the homework, and for me, are going to be real equations in the real world. Does anybody happen to know what this equation is for? The letters might give it away. Temperature, yeah. It's conversion between Celsius and Fahrenheit. So if I know Celsius, this equation is beautiful to convert it into Fahrenheit. Now, what temperatures do we normally know? What do we know in this country? Fahrenheit, right? We normally don't know shit about Celsius. What's a comfortable Celsius degree day? Anybody know?
17.
Some of you guys might. 17, yeah. I'd say around 20, right? 20 is like 80 something. But we don't use Celsius, so we wouldn't have a freaking clue. So rather have Celsius equal something to do with Fahrenheit, so I can convert from Fahrenheit that I know to Celsius. Do you guys see what I'm saying? So what would be the first step in solving this for C? Beautiful. Don't worry about the fraction yet. Right? This term has the C in it, so you want to get rid of the other shit. Subtract 32. Now here's a good question. Here's the thing that came up in the homework already, but I haven't talked about it yet in lecture. There is a way to do one thing to both sides to kill that 9/5. Multiply by, not 9/5. That would reinforce this guy. I want to kill him.
5/9.
5/9. If you multiply by the reciprocal, look what happens. Doesn't it make sense? How would I kill the 5 when I multiply by 5? How would I kill the 9 when I divide by 9? So how do I kill the whole thing? Multiply by the reciprocal. And of course you got to do both sides. So here the 5's cancel, right? 9's cancel, so I get left with C. So now I've got a formula for, if I know the Fahrenheit, I can convert to Celsius. So real quick, for example, if Fahrenheit temperature was 72 degrees, that's a decent day, right? 72 degrees, that's a nice day. Yes? No? That's sort of subjective, but come on, 72 is freaking nice. Figure out what that would be in Celsius. You might need a calculator. Maybe make it a little bit nicer. Give me a second. Don't use this number yet. Let me make it a little bit nicer if you don't have a calculator. Let me see if I can make it nice quickly. You can do it, Jeff. Yes. There it is, 77. Alright, that's a little bit warmer, but we'll see what it comes out to. Hopefully you'll see why it's nicer. So what do you guys, if you throw a 77 in, 77 minus 32 is what? 45. And what's nice about 45? 9 goes into 45. So 25 degrees Celsius would be a 77 degree day here, right? Okay. Sorry? Are you cool up to here? And then 9 goes into 45 5 times. 5 times 5 is 25. Yeah. Is that alright? You guys alright? Say again?
When you do that, we all kill them.
Of course, yes. No, I understand. One thing you definitely should be comfortable with in this lab, just in general in math, is plugging values in for variables. If I give you a value for a variable, you should be like, oh, good, I can do shit with this. What this is telling you is equations have purpose, right? And I can play with the equations to make it a more efficient use of the idea. And that's why we have to learn how to play with equations. That's bottom line. Yes.
If we were trying to figure out Celsius, would we just do the same thing? We just reverse it, right?
If we had a Celsius,
Uh-huh.
yeah, we would just put 17, like you said earlier,
Uh-huh.
17. We'd put it in here and see what that is
Uh-huh.
in Fahrenheit. Yeah, exactly.
And then, okay.
So it's better to have both of these equations. Do you guys understand? This equation is the same as this one. They're exactly the same. There's one solve for F, one solve for C, but they both have the same values. Okay, I like it. I ended up not using the green book at all. I always forget I have it. I have a... Please tell me I brought them. I was supposed to. I thought I brought them. I might not have brought them. Oh well. In which case, we'll have to do this. Oh, that sucks. Oh well. I love it when I print it out and then I just leave it on the printer. That's always the most useful. Okay. So let me do this. Let me run back there real quick. Let me give you guys a problem to work on while I'm out running. Here's two problems to work with. And I'll be right back. Second one will be a little more difficult. All right, I'll be right back.